I answered the wrong answer. There's an 80% chance you got the wrong answer.
All right, so leave him alone. I'm not sure. Cartesian. It's Cartesian. It's called Cartesian coordinate or rectangular coordinate. So this is they either have this name or this name. So you can convert one thing to the other thing. I'm just gonna go through it really fast for you guys. It's kind of review. So remember that we have two. We're just gonna do 2 comma -2, and this is a rectangular coordinate. So with rectangular coordinate, I can convert to polar. I just using this equation here. So tangent of theta is equal to 2 over -2. Wait, hold on. -2 over 2. It doesn't matter. But -2 over 2, y over x. So tangent of theta is equal to -1. Now, since it's a 2, -2 is which quadrant?
Or no,
I was gonna say.
I'm thinking about something else. My brain's going way forward.
Okay, so it's gonna be 2. It's gonna be here. So therefore, the theta has to be around because it's in the 4th quadrant. So the theta has to be 7 pi over 4 because you have to determine based on the quadrant you are at. You know that this is going to be -1, so it has to be 7 pi over 4, but in terms of that quadrant. So then you can figure out 2 squared plus 2 squared equal to r squared. R squared is equal to 8, and r is equal to 2 square root 2 plus minus. So therefore, it's going to be 7 pi over 4 and then 2 square root 2. And that's how you convert to a polar coordinates.
Shouldn't it be the other way around?
Yeah.
Oh, sorry, I wrote it down. Good question. So it'll be 2 square root 2 and 7 pi over 4. Now, if you want to change it back to Cartesian, you can. So x equal to r cosine theta, and then y equal to r sine theta, and just implement it in 2 square root 2 times cosine of 7 pi over 4. That becomes positive square root 2 over 2. So it end up to be 2. And here is 2 square root 2 times sine of 7 pi over 4. So that's equal to 2 square root 2 times negative square root 2 over 2. So this is -2. So therefore, you convert back. And remember, this just some basic things that we covered yesterday.
So the locations are actually the same because their distance from the center is the same.
Yeah, it is the same, but 7 pi over 4 is going to tell you the angle from here to here. So that is the angle.
Their distance from this origin is the same.
Pretty much. Yeah, they're the same points, just in different systems.
So a lot of you guys, I just want to point out, a lot of you guys says, do I need to memorize this? But you already know this from SOHCAHTOA, right? SOHCAHTOA says what? Cosine theta is equal to x over r, which is adjacent over hypotenuse. And this is sine theta is equal to y over r, which is the opposite over hypotenuse. Okay, so those are the basic thing. So we're gonna go in further to talk about how do you changing equations. So let's start with the basic equation, r equal to 2. You actually already know how to do this.
R equals 2 what?
R equal to 2, how do you change it to rectangular equations?
What about don't we need an angle?
Nope, we don't.
Oh, it's x squared plus y squared equals 2 squared.
Yeah.
Well, what you're gonna do is you square both sides first. And that's gonna be r squared equal to 4, and r squared is equal to x squared plus y squared is equal to 4. Does that make sense? You're just changing from this is a polar equation, even though it's r equal to 2, it doesn't look like an equation. They are. R equal to 2 is much simpler to rectangular. You actually change it back to rectangular without a hiccup. Okay, Jonathan, make sure you read here. The next one is actually kind of different. The next one is you can also just like instead of give you says x squared plus y squared equal to 4, I can really easily give you the x equal to 5 or y equal to 5. That can be things like that. So in this thing, in this second type equation, I can give you data is equal to pi over 3. Or pi over 4. Let's do pi over 4, it's easier. So if I do data of pi over 4, how do I use the equations? How do I use those equations here? Which equation I'll be using? Tangent, good. So what you're going to do is you're going to tangent both sides. And that's equal to 1. Does that make sense? And tangent you can convert to rectangular. That's just y over x. So y equal to x. That was the equation. So even though this is a polar, it doesn't look like a polar. It's still data. It's like it's saying x equal to 5 or y equal to 5. It doesn't look like an equation, but they are still equation. They might not be a function, but they're still equation.
How do you make the y over x equal to 1?
Because tangent data is equal to y over x.
Oh,
So you just convert one thing to the other. Sometimes you have to use the first two equations as well. Sometimes you have to deal with that as well. So that just say r equal to, I forgot which one is it. 6 cosecant of data. So you have something like this. And you say, wait, how do I convert to rectangular? Rectangular has to be everything in terms of x and y, right? So what's the best way to do this one?
Is that cosecant?
Yep.
R equals 6 cosecant.
Theta.
Well, cosecant is just 1 over pi. Then I can flip sine to the other side, so it's r sine equals 6. And then
One more step.
we bring the r to the other side.
No.
X equals 6.
No, almost. Y is equal to 6. Why? You can think about r equal to 6 over sine theta, right? And you can change to the other side. And then would that be just a y? And then we just change it to rectangular.
This is just a lot of trick.
I mean, that's not even that bad. That's like very easy trick compared to what you're gonna do later.
Oh, we're gonna have this later.
Yeah, because you have to get integral of polar equations. So
Like, I know that's cosecant.
so yeah, this is just the beginning stage. But it's okay, it's not that bad. You just have to know your trick stuff. At least I think.
Oh, okay.
Now so you can convert like to rectangular to polar, just some basic information. They're not like something crazy. So I'm just gonna kind of cruise through it. So r equal to 6 cosine theta. Now this one is actually interesting. So how do you hit 2 birds with 1 stone? Right? So really hard. It has to be in the right direction.
Coordinates or
for this.
rectangular?
How do you change the rectangular equations? So how do you hit 2 birds with 1 stone? So that's the thing. So can you provide me ideas like how do I do this? This one's kind of tricky. So and just kind of like think about puzzle how do you figure out how to hit 2 birds with 1 stone? Which is how do you get two situations happen out of here at the same time? So how do you happen? So there's a 4 situation: x equal to r cosine theta, y equal to r sine theta, tangent theta equal to y over x, x squared plus y squared equal to r squared. So how do you hit two situations at once? And with the situation, so r equal to 6 cosine theta.
Wouldn't it be the same as
Can't you
the
turn it?
previous one, like similar to that?
What would you do?
Just do r theta equals to 6 and then x equals to 6.
I don't think you have enough for that. I don't know. I don't think you have enough for that. Yeah, Jonathan?
Would it become, because couldn't you just divide both sides by 6 and make it r over 6 equals cosine theta and cosine theta?
R over 6 is equal to cosine theta, and then what do you do?
Cosine theta is equal to x over r is 6, so R would be 6, since R is on the bottom, and then since R is 6, it's 6 over 6, X is 6. Does that make sense?
Yeah, but I don't think that's gonna lead to anywhere. You go ahead and try it. And show me.
It's just
Can we substitute R in the form of x over cosine theta and then make the subject x, so x will be 6 cosine.
Yeah, but you still have cosine theta.
What are we trying to do here?
You're trying to convert to everything in terms of x and y.
but
Yes.
Okay, well, you can replace the r with square root of x squared plus y squared.
Something with tangent, isn't it?
huh?
That's from the other side. Square root of x squared plus y squared.
Yeah, but that doesn't work because you still have cosine theta.
I mean, I found X.
Well, cosine theta equals x over
Yeah.
r. So you get rid of the cosine theta by putting x over square root of x squared.
Try it.
plus
Go
y.
ahead and try it. Stop talking to try
Oh,
it.
I
Try it and show me.
think I have the way I do it.
Okay, so y gone to tangent. So 6 sine.
So I'm gonna show you how to hit 2 birds, 1 stone. I mean, you can obviously square both sides. You got r squared, and you got 36 cosine of theta squared. But that doesn't hit 2 birds, 1 stone because you got r squared. R squared can change it to x squared plus y squared. But here's the cool thing: is that you learn how to think. If you think about it, it says, well, instead of square both sides by r, can I multiply by r on both sides? And you're still gonna get r squared, right? So you're still gonna get r squared. So r squared is equal to 6r cosine theta. Then can I just get x squared plus y squared equal to 6x?
Oh.
Then why they
Oh, by the way, what equation is this?
Standard form?
I've
Oh,
never
this
seen
is
that before.
clerical?
Circle, thank you.
6
X squared plus minus 6x, right? Minus 6x plus y squared is equal to 0. You can actually complete a square. So that's going to be x squared minus 3 squared. You're going to plus 9 on both sides.
Huh?
So that's going to be plus y squared 9. So therefore, it's actually, this one's x, sorry. This one's going to be 3, 0. And the center is at 3. And radius is 3, sorry.
That's the thing we learned in pre-cal.
I got 6, 0.
You should know.
How did I get 6?
I don't know.
Can I try to explain to you what I did? Because I got 6, 0. I don't know how I got 6, 0.
I don't know.
Could you zoom back in on that?
What?
I think I did better than John.
How much money on a bet?
Oh.
Let's place a bet. Let's go who John versus.
Like, you got 11 right on the entire test.
Yes.
That's like,
That's a lot for a
that's
first.
statistically awful.
No, it's not. My AP Calc class last year, I got like a 1 or a 2 on the first pre-test we took, and then got a 5 in the actual.
I didn't like do anything in calc last year.
Okay, so anyway,
I think you got
so are we okay here? Am I going too fast?
No.
9.
Okay, so this is an introduction. You should learn that in the pre-calc, I'm gonna teach you how to sketch one graph. Well, first of all, I want to show you how beautiful polar can be. So I'm gonna show you in terms of equations go. Let's just say R equal to let's just say it's, I don't know, 2 sine of A to the theta. Okay, so add a slider. So you see that there is a circle, right?
Yeah.
So I'm gonna put a slider here.
Oh my god, is it gonna like flatten out?
Oh, that's cool.
Whoa.
What is that? Trippy.
Why doing that?
Whoa, that's cool.
How's it keep doing new things?
Yeah, I put an A as a slider, basically just change the angle. So that every time angle changing, that is gonna affecting the thing. Every time the coefficient change in front of the angle is changing, it's affecting how many paddle is going to be. So some of the easy thing that to think about, that's the things that we don't have time to. At least when I teach it, I don't have enough time to cover polar. I think I teach 5 years of pre-cal. I only 1 year got to do the polar. But yeah, it's definitely the core part of the things. So a lot of times that you're gonna say, okay, well, how is this coming? So a couple of things I want to show you is if just stick with integers goes, then I don't know how to do just integers. There's a step, so let's do one, and so basically just deciding how many petals is, and if I ever stop, if I that's not, don't worry about -1, so to worry about 0 to 10.
I remember this paddle shit.
So, but the interesting thing is, I'm gonna pause here. That's just gonna be 1, and that's actually 20 petals if you count it up. So the weird thing is this: if it's even, it's gonna double. If it's even, it's gonna double. If it's odd, it's gonna be the same. So let's just say if I change into 5, and it would be exactly 5 petals.
If you did 6, it'd be 12.
Yeah, it'd be 6, it'd be 12.
How did that make happen? And 4 would be 8.
4 would be 8. Yes, 4 would be 8. Okay, so that's how the petals work. Now, I'm gonna show you how to sketch it the first time. But basically, if you double it, and then they can be similar thing. They will have from like a Nemicon graph, Cardinal graph, dipoles, and convex. You can have all those graphs. Now, I don't know how extent of AP exam gonna goes. I don't think they care if you know the name of the graph. So I'm not worried about that part, but I'm just gonna worry about, what happened. How do you sketch the first thing? So I'm gonna show you how to do it really quickly. And then we're gonna kind of sketch it in, and we're gonna show you how this graph come in play. So I'm only gonna show you once because it's not important. AP exam is not gonna ask you how to sketch a polar equation. But they're gonna ask you, let's say, the area within the polar equation. They're gonna ask you the slope within the equation. That is the main part of the AP exam. Now, I'm gonna show you how to sketch it the first time. So I'm just gonna say, hey, let's graph this R equal to 2 cosine of 3 theta. So if you know this is an odd number, what does that mean? How many petals it's gonna get?
It's gonna get the same amount.
It's gonna get the same amount, which is 3 petals, right? But I'm gonna show you how those petals come in play. So what you're gonna do is you're gonna plug in some the thetas and the r's. So let's just plug in 0. Let's see what am I gonna get. If I plug in 0, what am I gonna get? 2. Good. What happens if you plug in pi over 6?
Pi over 6 is actually equal to pi over 2.
Is it 0?
It's 0. Good. And let's go into pi over that's pi over 3.
That's
-1.
Wouldn't that be
Negative 2. Good. How about pi over 2?
It would be
0. Okay, so at 2 pi over 3, it's going to be 2. And we're just going to keep on going, and then you can find out that eventually you're going to have something like this. And I'm not going to do it on a polar axis, even though I should, but I'm not going to do it. And there is smaller increment you can plug in, but I'm not going to go through that. So I'm just going to show you really, really fast. So at 0 is going to give me 2. So 0 is the angle, right? R is 2, right? Pi over 6 is roughly where? Pi over 6 is roughly right here, right? But at here, then you actually can end up to be here.
Yeah.
So the graph is actually going to go like this.
Oh, that's gonna make
It's going to go in like this. Because if you plug in multiple angles in there, let's say pi over 12 in there. If I do pi over 12 is 3 to is pi over 4, and pi over 4 is going to square root 2 over 2, it's going to be square root 2. So I here it's going to be end up to be like a square root 2 if it's a halfway. So it will actually bend backwards. So that's going to be like this. Now what happened at 3 pi over 2? At 3 pi over 2 is going to be somewhere around this region right here, right? Does that make sense? And then you're going to have a radius of -2. So it's going to be on this side. So it's going to be -2. So it's going to be come up to be like something like here. And then at pi over 2 is going to go back to 0. So pi over 2 is going to go back to 0. So it's going to be like this. So they keep on bending, and it's going to form a pretty cool graph. Eventually, it's going to be formed like this. And it's going to be like this. And it's going to be like this. So it's going to be a 3-petal graph. So you have to understand the angles. And you have to understand the angle, you can have a negative R. R is going to go backwards. So this eventually things. But I don't have a lot of time to go through how to graph a sketch polar graph. But this is just a general idea, how to fast track of this. But what is the main thing that you will be asking? You'll be asking is something that just said, something like this, you had to pay attention, is find the horizontal or vertical tangent line or finding slope of a function. So I'm gonna, Bobby, is already finished?
So,
You're not finished yet? Okay.
you said you were done. I never said I'm done. I have 2 questions left. You want me to just like do them real like this?
It's okay.
Imagine if you get to 11.
Who wins that? I'm just saying.
Wait,
that's-
who, money's on who though?
Huh?
Money's on who?
I got my money's
I got money, I know, but he had a
money's on Jonathan.
I got money on
Money on Jonathan?
Wow, okay.
Good at you.
$5 on Jonathan?
Okay, that's it.
Brazilians are better than you.
They're really not. You guys like to house Nazis.
And y'all were.
You house Soviets, yeah, but that's a little better. You must cause the nuclear war.
He's saying it's not really better.
Okay, so how much time I have?
Like 20 minutes.
Okay, good. I have enough time. So let me see if we can find the questions.
Why?
Are you done, Bobby?
I want to. Hold on. Got some last ones. Yeah, you're not gonna get it.
I think you fill it on the question. Did you fill it on the question?
I'm on 92 now. That's true. But John did not fill in the question.
Yeah, I had a lot of empty questions.
Why would you-
Just Christmas tree at the end.
You didn't have time to Christmas tree?
Yeah.
So, how do you find dy dx equation tangent line if I give you a polar equation? Okay.
Wait, say that question again?
How do you find the slope in the polar form? Okay.
Slope of what? It's a point.
So yes, but you guys still have a slope. You just any type of point that has some type of slope.
In
So,
relation
for
to what, the
example,
origin?
like this part here, let's just say at pi over 6, there's some type of slope right here, and this is gonna be dy dx.
So they convert to X, or do we just do
Yeah. So what happened is you have to understand dy dx. So this is something you need to know. Is dy dx is equal to dy d theta over dx d theta. Well, if you keep change flip, d theta is going to cancel out, right?
Yeah.
Okay. So now you can find the dy dx because this you can find dy dx. So what kind of equation? I'm gonna give you something that says r like r equal to sine theta, like something like this. And we say, hey, can you find out the slope at when r is equal to pi by 4?
You can do that either.
Yeah, no, theta, sorry. Theta is pi by 4. Well, actually, theta is pi by 4, yeah.
Mr. Ye,
Mhm.
so I'm a little confused on this last one with the answers, but this is 69. Should I just pick it?
Yeah.
It'd be pretty fun.
If you got it right, it would be good.
If I got it right,
Imagine if 69 was the right answer.
the right answer would be pretty good.
That should be on the memes of that year.
You should do that, like on one of our tests, make the other 69 on purpose, and then make the other answer correspond.
Okay, well, do you want to take a derivative of r equals sine theta?
Well, so you have to figure out what is the x and what is the y first, right? So first of all, let's figure out what the r is. So if theta is equal to pi over 4, what will happen to be r?
R would equal sine of pi over 4, which is square root 2 over 2.
Square root 2 over 2. Good. So we got x and y coordinates.
Just want you to know, I drew a little thingy on here to spin my pencil to figure out the right answer, and it landed on 69. So
So then take it and
I
shove
just
it and put it in.
I'm done. Let's go. Oh my god. Oh wait, hold on.
Oh, what an idiot.
All right. So that's equal to the thing. So then you say, okay, well, can I take dx dt dx data first, dy d data? Wait, who? Who? Oh, Gabby's on here? I didn't realize Gabby's on here.
So you're gonna grade it right now?
Yeah.
I'm gonna give it 12.
Why don't you get higher than me? Okay, 30 to get a. What is it?
You did better than John by
What do
one
you get? What do you
question.
get? What do you get? What do you get?
You got 12.
I knew it! I knew it! But he answered every single one. If I were to say, I'm just gonna put all A's. But if I put all A's on the empty ones, I'm gonna get, there's no chance of not at least two questions correctly. You didn't use your time correctly, that's all. Neither did you, you weren't having more time. I have a 5-4 plan. That's bullshit. That is a bullshit. 2 by B's and that's why you get going slower. I know that's bullshit. They're at the same shit.
Okay.
They're at the same time shit. Where she got extra time for the diabetes. You know how quickly it takes you to check your blood pressure. Okay, you know, sugar, not pressure, sugar.
I don't know, actually. I'm going to work it out. I don't know. Okay, so what we're going to do is we're going to take care of this. We're going to say it's x. It's possible to be anything else. I don't know. What is it? So x equal to, first of all, let's write in this form. So there was an x equal to r cosine theta, right? And what is r? R equal to sine theta, right?
Oh, we know this.
Wait, was 69 correct?
I don't know. I have no idea.
But now you're way behind, buddy, so congratulations.
Guess so.
And I don't know if this question is right or wrong because I just kind of think of a number inside my head. So I don't know if it's come out to be infinity or not. So we can try it. So do you understand why I change it? So this r is equal to sine of theta, right? And then so we got an x part of the thing. So we can take dx dt's here. Now, what happened if y equal to r sine theta? Now, y is equal to r. This is going to be sine theta times sine theta. So y is equal to sine squared theta. So what I'm going to do is I'm going to take a derivative, dx d theta.
What was the point of finding r if you're still using sine theta? Like, what was the point of doing the whole?
This is the equation. This is what equation is. Now you got to plug it into the
Yeah, why
parametric
did you plug
equation.
in the square root of 2 over 2?
I haven't been writing down my objection.
Like, what was the point of finding
Yeah.
it if you didn't use it?
Yeah.
We're going to have to take a derivative after. We're going to have to take a derivative of sine theta cosine theta.
Oh, it's the
Right, and why not just plug in, instead of putting sine theta, why not just do square root of 2 over 2? Like, what was the point of?
But you had to take a derivative first before you plug in.
Okay.
You cannot. You are in the term of x right now. You haven't get to dx dt yet. So you want to get dx d theta and the dy d theta. So I'm going to take a derivative of this. What happens if I take a derivative of sine cosine theta?
Negative sine squared theta plus cos squared theta.
It should be cosine squared theta minus sine squared theta. Good. That should be what? Actually, that's the cosine of 2 theta, right? It's called double angle identity. It's double angle identity.
Use the product rule.
And what happened dy d theta?
2 sine theta cosine theta.
2 sine theta cosine theta, which is also known as sine of 2 theta, right? Okay, so you got y over x, so it's dy dx is equal to dy d theta over dx d theta, right? So
I see where this is going.
now you have to plug in what? Cosine of 2 times what?
Wouldn't it be?
This one is going to be pi over 4, so it's going to be pi over 2.
Mr.
It
A,
should be
it
flipped,
should
right?
be sine over cosine.
Yeah, it should be sine.
Oh, sine 2 theta, yeah.
So it will be tan to theta.
Sine. So you can do sine of 2 theta over cosine 2 theta, and which is what?
Tan to theta.
Tan 2 theta. Now if I plug in tangent of pi over 4 times 2, which is tangent of pi over 2, which is what?
Infinity.
It's undefined.
So you can't.
So it's probably a vertical tangent there at that particular point. So if you graph it, it's going to be a vertical tangent. And why is a vertical tangent? If you go look at it, let's type in r sine theta right there, right? R sine theta here. So r sine theta, so that's just going to be r sine of theta here. It is, you look at a pi over 4. Pi over 4 is probably right this point right here. Right on 0.5 and 0.5. Do you see that? That's actually a vertical line. The slope is actually a vertical line. So we actually find dx dt, dy dx at that particular point. Does that make sense?
Yeah.
So it's actually undefined slope. I just picked a wrong number. I should pick a number that is defined, but I didn't think about it. So I pick a wrong number. Otherwise, you can get the different values. You might get some type of value of slope. I think on your things, what I'm going to do is I'm going to pass you back the test. Now, this test you guys can keep because this one is I actually find it online without going to AP classroom. Now, rest of the mock exam, please don't take a picture of the mock exams I'm giving to you. You guys can check it, the answer in here, but not taking outside with you, not taking picture with you, because I get in trouble if that happens. So I don't want you to take a picture of the mock exam. This is actually I found online, so it's okay. Okay, So Bobby, you can get this back. Yeah, I can go back to the problem.
I am so good at math, getting a 12.
Bobby, if I Christmas treated, I probably would have done 13.
But you did. That's true. You didn't. You didn't, and that's the decision you made.
I didn't get it.
And I'm gonna give you answers also. Answer.
So who's the real winner here, Bobby? Who's the real winner?
Mandy.
39.
Oh.
Joanne?
Joanne.
How many do you have?
Oh, Jonathan. Asheville. Wait, Logan. Tyler. Line, Ian. Luke. Thomas Schwartz. Julia. I'll give you the answer.
It's okay. I don't care.
Yeah, I'll give you answers. Kathy is not here.
If I were to put A, let's see what I would get if I put A.
Nicole.
Okay, dude.
Logan. And Eva. What?
Yeah.
Yeah, you can. I'm gonna give you an answer. Give me a second.
Obviously, I wouldn't have gotten the zero.
My grade in your grade book.
Yeah, I'm not worried about that. Okay, so let me give you an answer for the start from the first one. You can go in the circle. Use a different color pen on your thing. Don't put it on a Scantron. Just put it directly on the paper. You can put it on the Scantron, but you can directly on paper. You can see it. You don't have to look back at the Scantron. You see what I'm saying? Okay, number one is C.
Got that. Let's go.
Number two is a B.
Wait, where did
Yeah!
No, Jonathan, mark on your paper. Mark on your actual test, not on Scantron. So that way you can go back and do correction on all of them.
I got one and two.
I didn't do it auto. It's probably you did auto.
Yeah, no, I did.
Okay, then that's not my
Right
fault.
on the Scantron instead.
Okay, fine. Okay, so number one is C. Number two is B. Three is D.
Yo, I'm 3 to 3.
Four, shut up. Four is E. Five is C. Six is E.
Wait, 5D?
Yeah, five C.
6.
Six E. Seven is A. Number eight is B. Number nine is A. Number 10 is B. Am I going too fast?
No, not fast enough.
Okay. 11 is E.
11 E.
E.
Wait, why is 11 E?
Number 12 is C.
Oh.
What'd you say? C or E?
C. 13 and 14 both E. 15 is a B.
It's a B?
B is a boy.
B.
B is a boy.
For what, 15?
16 is a A. 16 is A. 17 is E. 18 and 19 and 20 are B. B is a boy.
Wait.
18, 19, 20. B, B, B.
Wait.
What have agreements?
Wait, what was 17?
17 is E. 21 is D.
1890.
21 D is a dog. 22 is a boy.
22 is a boy.
Wait.
23 is a dog.
Please.
Oh, I got that one right. Let's go.
24 is C.
Charlie.
Charlie.
Last try.
24 is.
25 is a boy.
It's a boy.
25. Why are all the pages back?
I'm sorry. 26 is A.
Damn.
Yeah.
27 is D.
We're gonna run out of time when you. Just like the original test.
28 is B.
B. 27.
27 is D.
EA Sports.
B.
B is a boy.
B.
What about 27?
Okay.
27 is a dog.
So 27 is D and 28 is B.
Yes. 29 is C.
Yes. Let's go. That was a good one. Yeah.
30 is E.
Wait, what's 29?
29 is C.
30 is
30 is E. 31 is a C. 32 is E. 33 is A.
Please slow down.
Okay,
faster.
C, E, A. For 31 is C, 32 is E, 33 is A, 34 is D, 35 is A, 36 is C, 37 is B, 38 is C,